Hello everyone, I will discuss problem E of Codeforces at around 150. So the problem statement says that you are given a square matrix of size n cross n and you are also given an array A containing elements AI. So the elements of this array tell you how many cells in the matrix are blocked for that column. So if this is how the array looks, then for the first column, the first 3 cells will be blocked. For the second column, nothing is blocked. For the third, the 2 blocks are blocked, and so on. And for the last column, all the 5 cells are blocked. You need to place in the empty spaces which are not blocked a total of m integers, and in each cell you can place only one integer. So for example, if m was equals to 12, then this is one possible configuration. You can place them anywhere, and you cannot place them at the blocked cells. The question asks you that you need to place the elements in such a manner such that the beauty or the score of the matrix is maximized. So what is the score? Score is defined as the number of elements or the number of j uh, such that the element numbered j and j plus 1 occur on the same row. So if this is a row, then these two must be present on the same row and they must be adjacent. So j should be on the left and j plus 1 should be on the right. For example, in this matrix, if you want to find the score, then you can see 6 and 7 are together. 7 and 9 are not a good pair. 8 and 10 is not, but 10 and 11 is. And I think we have only two such pairs here. So the answer for this is 2 for this configuration, and there may exist a configuration with a better answer. Please note that the pairs on the columns are not considered. So for this, for example, this 2 comma 3, even though they are kind of adjacent in vertically, but they need to be present on the same row. And also a configuration like if you had something like 11 and 10, this would also not be a good pair because 10 needs to be on the left and 11 needs to be on the right. Okay. So how do you solve this problem? Well, the thing to note, like the way we will solve it is we will consider placing the elements along each row. Okay. So for example, if I want to place the elements in the first row, I can see that I have some segments. So this element is blocked and this element is blocked, right? These two elements are blocked. So this is one empty segment where I can place elements. This is another empty segment of length 1. This is another empty segment. So basically we are talking about dividing the rows. So we will divide the rows into segments. And these segments will be continuous, and they will only contain non-blocked cells. So if I go to the next slide, this is how the segments are going to look. So the green boxes are the segments. So if we look at maybe this row, the third row, this is one segment, and then there is a blocked cell here. So we cannot place anything, and then this is another segment. Okay. So what I've done is simply I have extracted all the segments from the matrix. So ignore whatever is written here, but just look here. So basically for this matrix, and given the configuration of the blocked cells, there is one segment of length 5, another segment of length 5 along a row. There is another segment of length 4 here. Then there's a segment of length 2, and then there are segments of length 1. Now these segments have some properties. Okay. Number 1, the segments can be treated as independent. So these are independent of each other. Why? Because if you're talking about two segments on the same row, then they will be separated by some cell, some blocked cell. So it doesn't matter what you put here, and it doesn't matter what you put here. Like these two will never be adjacent, and they will not contribute to the score. Also, now if two segments are like this and this, they're not on the same row, but they have some columns overlapping. That also doesn't matter because it doesn't matter what cells you are placing on a column. What matters is how the cells are placed on a row. So the segments are independent. Second thing is, and this is now we are moving on to the solution. Suppose we want to fill the elements in a segment. Okay. Suppose we have a segment of length 5, and we want to fill the this segment completely. Okay, we want to fill this segment completely. So um, the elements in the segment should be continuous. For example, if m is equals to 15, so we could place elements like 10, 11, 12, 13, 14, and 15 here. I think 3, 4, 5, it would be 6. So the in each segment, the elements which are placed should be continuous. And why is that? Well, the reason is, suppose instead of placing a 13 here, first of all, for this configuration, the answer would be 5. Like you will add 5 to the answer, because this is one pair, this is one pair, this is one pair, this is one pair, and this is one pair of adjacent elements which are good. But if you had maybe placed, instead of 13, you had placed something like 4 here. So your array would look like 10, 11, 12, 4, 14, and 15. Then what you are actually doing is, this 4 will never form a good pair with this. This 12 will also never form a good pair with 4. And um, so you have already reduced your answer by 2. And wherever that 13 was going to go, that 13 can only form a good pair with 14 on its right or 12 on its left. But then that is also not possible, because 14 is present here and 12 is present here. So this will also lead to some loss of the score. So the elements, if you are placing elements on a segment, in this segment or in this segment, whatever segment, you need to place them in a continuous manner. There should be no empty spaces in a segment also. Second, the third point is, we will start to fill the segments with the maximum length first. We will start to fill the segments in a decreasing order. And for example, in this configuration, we will first fill, suppose m was 15. So what I'm saying is that the optimal arrangement will look like this. The segment with length 5 will be filled with elements from 1 to 5, because these are continuous. And uh, the segment from of the next segment of length 5, since you are filling in decreasing order, will be filled with the next set of 5 elements in a continuous manner. Then the segment of length 4 will be filled with 11 to 14, and the segment of length 2 will be filled with 15 only. And then we have filled all the elements, so we can ignore and we don't need to fill the remaining segments. Also keep in mind that this 2 segment, even though it contains 2 elements, it is only being filled by 1, because we don't have enough m lifts. Now why is this optimal? Why are we filling them in a decreasing manner? Well, if you look at it like this, right? Suppose you had a segment here, and then you were filling some other segment. And like I said, you are filling them in a continuous order. Suppose you filled element 1, 2, 3, 4, and 5 here, and you are filling the element 6 and 7 here. Okay. Your answer will be, there will be some pairs like these, which will be added. There will be some pairs like these. But if you look, there is also a pair of 5, 6, which is not being added, because these 5 and 6 are on the on different rows basically. So then suppose then you had placed another um, uh, in another segment, maybe you have placed element 8 and 9, then the 7 and 8 is also not going to be added. So basically what you want to do is, you want to minimize these sorts of pairs, like 5 and 6, 7 and 8, basically the last element and the first element of the next segment. And this can be minimized if you minimize the number of segments. So you basically want to minimize the number of segments that you are filling, and because of that, you want to fill them in a decreasing order. Okay, if you fill them in a decreasing order, then the number of segments will be minimized. So this is the optimal arrangement. So the problem basically boils down to this: you need to find all the segments, and then you just need to sort them, and after that you can just greedily fill them. So then suppose you have a segment of length 11 and your m is 20, so you will fill the first 11 elements here. Then the next segment is maybe of length 7, so you will fill the next 7 elements, and you will keep filling on until you cannot fill. And then if you're filling it completely, then you will add 10 to your answer. If you're filling it completely, you will add 6 to your answer. And 11 plus 7 is 18. The next segment is maybe of length 3. So you can only place 2 elements here because you're left with 2 elements. So you will add, instead of adding 3 minus 1, because you're not filling it completely, you won't add 3 minus 1, you will instead add 2 minus 1. So you will add 1 only for this segment. So the last one has to be handled separately. So basically you have to solve this. You can attempt this part on your own now. I will explain how to do it. Um, so if the first way to do this is actually to create an n cross n matrix, and you know what cells are blocked, you know what cells are empty, so you can iterate over each row, and then you can just find the segments, continuous segments, and you can add them to a set. But that cannot be done in this case because n cross n will, I think, be around 1 e की power 10, because n is 2 into 10 power 5, so it will be order of 10 की power 10. You cannot make such a large matrix. So you need to smartly find all the segments. How would you do that? So the first thing that I did was I modified the original matrix, and instead of question said that elements from the top were blocked. So I looked at the matrix from the bottom, and instead of saying that the elements from the top are blocked, we can say that the elements from the bottom are blocked, and like the top elements are empty. Okay. So, and this is like the original A matrix was 2 0 3 0, I think, 4, and suppose this is how your A matrix looks. So you have 2 elements blocked here, then 3 elements blocked here, 4 elements blocked here. You just sort of reverse it. So you called a new matrix which stores the number of empty blocks from the top. So this will be basically n minus whatever this is. So this will be 4, this will be 6, this will be 3, this will be 6, this will be 2, and this will be 6. Okay. Now I want to find all these segments. So suppose I look at this, okay, and I am uh, looking at rows like one by one. So what I create is, let me create a matrix. One second. Okay, this was a configuration for this, but I have created a different matrix here. So uh, forget this matrix. Let's talk about this matrix. And for this matrix, the A value, like the empty cells, is something like this. So you have 4 cells. Suppose you have a matrix like this. You have 4 cells here, 3 cells empty here, and this is a 5 cross 5 matrix. So this would be 1 0 1 2 3 4 5 1 2 3 4. Oh, this is a 6 cross 6 matrix. My bad. So you have got a 6 cross 6 matrix, and this is how the empty spaces array looks like. So we want to find all the segments. So what we can do is, in this range from 0 to 5, this is how our A looks. Let's try to find the minimum number of empty spaces. Okay. So this is 2. So what that means is you can have exactly 2 segments of length 6, because all of these columns have at least uh, 6 spaces empty, right? All of these columns have at least 2 spaces empty from the top. So you can have exactly uh, 2 segments, and basically these will be uh, these 2 segments, right, of length 6, and that is the maximum length. Basically we are trying to find the segments um, for each row, but we are greedily uh, trying to find the minimum element, and based on that we can deduce, okay, this much segments of this r minus l plus 1 length will exist. Now you have made 2 segments of length 6, and what that has done is basically you will now create a new array of empty spaces. For this row, the first two uh, cells are now also blocked. So your empty spaces will reduce to 2. Your empty spaces for the next column will reduce to 1. For this, it will reduce to 4. For this, it will also reduce to 4. For this, you've now everything because you have made these two segments. So now there are no more empty spaces here, and here the empty spaces are reduced to 4 also. Now we have now the next thing to note is whatever the new segments will be, they will either be in the range from 0 to 3 or in the range from 5 to 5. Basically, there will be no segment apart from the two that we made, and we have added that to a set uh, that will start here and end here, because uh, this has no more empty spaces. This is a 0 here now. So all the segments will now lie in this range and this range separately. So we can recursively solve for this range, and we can recursively solve for this range. So when we are trying to recursively solve for this range, the A matrix that we are concerned with is only the first 4 elements. And when we are solving recursively for here, we are only concerned with this fifth element. The 0 is not going to be used. So now you want to solve for this. So you have now try to find uh, the minimum element in this array, which is 4. So that means you have got 4 segments of length 1, because it is from index 5 to 5. And here you now try to find the minimum element, which is 1. So that means you can have exactly one segment of length 4 from 0 to 3, because like this segment, you can have exactly one segment looking like this. And we have also considered these 4 segments. Now what will happen is your A matrix will change. So uh, for this call, the A matrix will now be 0, and like you can end here because you have only like one element remaining. But for this case, for example, the A matrix will now look like you have created one segment, so everything will be subtracted by 1. So it will be 1, 0, 3, and 3. And then you will recursively solve for this region and this region. So um, basically, you will recursively solve now for this range and then for this range. So again, in this range, suppose you're solving for this range, um, the minimum empty spaces here are now 3, and that means you will have 3 segments of length 2, which is because this is index 2 to 3, right? So 3 minus 2 plus 1, this is the length. So you'll have 3 segments of that length. And again, from here you will identify that you have exactly one segment of length 1, because the minimum here is 1. And every time you will add these values to a set. So we will create a set which will be a pair, and the first value will be the length, and the second value will be the number of such segments. So we are not like we are not iterating over all the segments. We are greedily for each R to L, for each L to R, we are greedily uh, finding the maximum, uh, the number of segments of length R minus L plus 1 by finding the minimum empty spaces in that range. And then we are recursively calling left and right. So the number of, so basically at each iteration, in each iteration, um, we are, since we are after finding the minimum empty spaces, we are subtracting all the elements. For example, um, in this case, right? In this case, 2 was the minimum empty space, and then we subtracted everything by 2. And then this column became 0. So after each iteration, one column will become 0. So we will have at most order of n iterations, and in each iterations we are finding the minimum. So it will take order log n time, and we are also adding it to a set. Um, so the overall complexity is, I think, of the order n log n only. Afterwards, now you have these segments, so you will greedily, like, then it's easy. You want to just greedily fill the segments. So you will start with the segment of the maximum length, and if you can suppose the segment of length 6 has 4 occurrences and your m is equals to 32. So you are basically going to utilize, you're going to fill all these 4 segments of length 6, because 6 into 4 is less than 32, and then your m will reduce. Then you will go to the next. Suppose your m will reduce to 8 after that, because 24 elements are already filled here, so you're left with m equals to 8. Suppose the next value was something like 4 comma 5. So basically you had 4 segments of, you had 5 segments of length 4. Now of course you cannot fill all of these, because in that case 4 into 5 is greater than 8, right? So what will happen is there is this segment of length 4 which will be filled, and the next segment of length 4 will be also filled, and after that the other segments will not be filled, because you have fulfilled your m. Your m is now 0 at this point, remaining m. So you just need to greedily fill. That should not be too difficult. The only difficult part was, um, I think, understanding how, in which order you are going to fill. So you identify all the segments, you fill them in a uh, uh, decreasing order, and to identify the segments you simply have a function from L to R, and you have a array A of empty spaces. You, number one, find the minimum index and the minimum value. To your set, you insert the pair, um, the value of R minus L plus 1, comma minimum value. So this much segments you can have of length R minus L plus 1. You then update your A. So A is equals to A minus. This updation will need a lazy segment tree. And you are going to update it with the minimum. You're subtracting the minimum value, and then you are gonna call your recursive function to L idx minus 1, and you're also going to call your function from idx plus 1 to R, because the idx index, this is L, this is R. So now this is completely occupied, because uh, its new value will be 0, because you're taking its value and then you're subtracting the entire array with it. So now these two ranges are what you need to consider. And yeah, that's all for the solution. I will show you the code. You need to have some knowledge of segment trees, particularly in this problem. Since you have range updates, you need a knowledge of lazy segment tree. Also, in my case, right, the segment tree that I created stores basically a pair. So the pair value will be the uh, like the value and the index in the original array where that minimum value was present. So I will show you the code. Initially, we were given the array, and then I converted it. Instead of the blocked spaces, I looked at the empty spaces. Then this is how many elements I want to fill. Then I update the segment tree with originally the empty spaces. So for each column, the number of empty spaces that it has, I'm updating the segment tree with that. And then I call a solver function. So the solver function is taking a range from L to R. It's taking a, make sure this is a multi-set. These are the set of segments, and they're segments, like I said, they're of type pair, and they're reverse sorted. And this is segment tree. So you try to find the minimum value and the minimum index. If the minimum value is not 0, then you insert that many occurrences of the minimum value in the segment tree, and then you update, you subtract everything by the minimum value, and then you recursively solve for the left and for the right. Segment tree, I will not explain the template, but just a few things. The segment tree is of type pair, but the lazy array is simply an integer, because it shows the additions that you need to do. And when I'm updating the segment tree, um, here you can see, so if start equals to end, basically if you're at the leaf node of a segment tree, then update the segment tree's index, like the first value in the pair is the actual value, but the second value in the pair is the index of that minimum value. So if for the leaf node you are updating the minimum value and then the index, and then that index is propagated upwards. Um, thank you for watching the video. If you liked it, then please consider subscribing. I will see you in the next one. Bye bye.